Okay, welcome to today product launching. As I said before, just now, I'm excited. I'm really excited about today meeting, especially for these two products. So we will spend maybe 30 minutes or less to present to you the products, and then we can have Q&A and discussion. Right. So let's go into the problem that we want to address. Because when there is a problem, there is an opportunity in the market. So as we know, we just ended the MCO for the first 2 months of 2021, and people are starting going back to the office. I'm saying going back means that there is no 50% work at home, there's no 50% work in office. Actually, now the company want most of the employees back to the office. So people are concerning about the air quality in the offices. Okay, it can be in a common public space. So there's four challenges I can see here. The first one is, of course, the spread of COVID-19. I'll explain further in terms of respiratory aerosol. Normally people sneeze or when people talk like me, I'm talking. So there's a lot of aerosol came up from my mouth, right? So that is a source of contamination, source of COVID-19. Challenge number two is basically the other viruses, bacteria, yeast and mold, pollens, allergens in the aircon room, right? Now, challenge number three is a fine dust and also particulate. Actually, indoor air quality actually define a clean workplace is less than 0.3 milligram per cubic meter. So the particle count has to be less than this. All right. Challenge number four is the TVOS, total volatile organic compound, right? In the offices, odors, the smell, vapors, chemicals, gases, right? These are the four challenges, faced for any officers or any workplace in terms of air quality. So this is an interesting publication. There's a link I share down underneath these slides. These studies shows that when people speak, right? So our aerosol actually fill up the whole room. You can see here, within 50 minutes or within 1 hour, we will fill up the room with our aerosol. All right. So that is a source of contamination, spreading of COVID-19. COVID-19 does not spread through airborne. It spread through droplets and aerosol, right? So further to this one, there is also another studies shows that how does the COVID-19 through aerosol, when we sneeze, when we speak, spread through the room. So this is a very interesting presentation. I'll show it to you. So this is a normal living room, right? With of course, this study is done in Spain. So if there is no mask, there is no precautions, steps to prevent COVID-19, so it will spread to the whole living room. But if we wear masks, okay, it actually reduces the infections. Only 4% will get, all right? If we have ventilations, if we have masks, if we have all the 3C, 3W ventilation system, A change, then if the spread of COVID-19 drop to just 1%. So that is how we reduce the spread of COVID-19 in a confined or in an aircon room. There's another example here, which is the schools. Okay, give it examples. There's a classroom of 24 students. 24 students. So how does it spread? So let's have a look. Okay. So there's no ventilation, just aircon room. Okay, when teachers speak for 1 hour, 2 hours, all right. So there is a 12 student will kena COVID-19, will spread to 12 person out of 24. But if they wear masks, if they do proper 3C, 3W, then we reduce to 5. Okay. But if you have good ventilations, either air change or filtration systems, it's actually reduced to just one. So that is how efficient, how important to have not only 3C, 3W, but the proper ventilation or air filtration system in an air-conditioned room, right? So that's why we think that there is a market for these solutions. Besides 3Cs, you know 3Cs is close space, crowded places, close contact setting. 3W, wear mask, wash your hand, wash your distance. All this is important, but now we are going back to office, so we should do more than just 3C and 3W. Like what the study shows, besides this, we need a ventilation. So what type of ventilation, you may ask? There is available technology out there that we can prevent the spread of COVID-19. There's two systems here. The first filtration system is called HEPA, high efficiency particulate air. I think you are familiar with these systems. For those that sell Aminafloor, BSC, they are all using HEPA filter or sometimes alpha filter. So the efficiency is 99.995% efficient for 0.1 micron, right? This is how they test the filter efficiency, right? So it will be able to remove respiratory aerosol, COVID-19. It will be able to remove the others, viruses, bacteria, allergens, and also fine dust or particulate. I'm not sure whether you still remember a few years ago, there's the Jelebu issues, all right? So HEPA filter can deal with Jelebu issues, right? So active carbon can deal with issues like VOC, formaldehyde from the furniture, the new furniture, the smell issues, the vapors, the gases, all right? So with this technology, we are able to address the 4 challenges I mentioned just now. So now I want to highlight these differences. Any one of you know the difference between HEPA H14 and H13? Anyone? You can put into a chat, right? What is the difference? Did you aware there's something like H14, H13, H12, H11, right? So because they classify the filters according to this number. Anyone know the difference between H14 and H13? Or did you aware there's a differences? Okay, so generally, HEPA filters, the mechanism behind the HEPA filters, you know that it's like a folded, filters. So there's 3 mechanisms that help HEPA filter to become a very good, very high efficient filtration for particulate, right? The 3 mechanism is this blocking effect, basically block, right? Number 2 is inertia effect. So the large particle will be trapped in the HEPA filters. And lastly, the diffusion. This is for fine, very small particles. It will be bind by diffusion effect. So using these 3 mechanisms, HEPA filter be able to block the fine dust or the bacteria. All right. So someone have helped me to annotate the graph here, which is relevant. All right. So what is the difference between H14 and H13 is the way they test the filter and how efficient is the filter after the test, right? Basically, they challenge the HEPA filter using 0.1 micron of particulate, powder particulate, all right? So in per liter of air, in the air, all right? So if only 0.005% of this particle can pass through the HEPA filter, this HEPA filter classified H14. So efficiency is 99.995%. So if 0.05% of 0.1 micron pass through the HEPA filter, then we classify this HEPA as H13, which is less efficient. It's only 99.95% compared with H14. Why I need to highlight this to you? Because when you sell air purifier, right? Then most of the home air purifier, Hitachi, most of them, right? Not all, but most of them is using H13. They are not using H14. For clean room, in industry clean room, your BSC, your laminar floor, they are using H14. Okay, so that is the laboratory grade or medical grade of HEPA filter. So this one we need to highlight to customers. All right, so let's continue. Okay, let's continue. Okay, so is there a market? All right, I want to ask these questions. Is there a market for air purifier in workplace? Is there a market? Because we never heard of this. I have a air purifier at home. Okay, so I bought it I'm the Jalabu time, I think 3-4 years ago, where my son has asthma. So I bought this air purifier. I'm quite happy with the performance. I bought exactly this system, Hitachi. It served my purpose. My small room, my bedroom. I have two, one room, one system. I spent 1,006, 1,007 4-5 years ago for these systems. It has HEPA 13 filters, all right? And I will show you how big is the filter, all right, later. And it is very small, 30, 300 mm times 320 mm H30 filters. It has multiple function, of course. It has humidifier, it has like pre-filters, yeah, and also, a few programs and those things. No maintenance and no one is giving me maintenance. So my HEPA filter, I'll show it to you how black is my HEPA filter, because it's difficult for me to buy from the market. I have to go back to Hitachi, right? So then come to another extreme. There's another market, which is the premium market. We call it the industrial clean room technology, either ISO 5, ISO 4, ISO 6 clean room standards. So those are FFU HEPA systems with fan, with HEPA filters. Those are customized solutions, very expensive. It is supplied by exclusive supplier, example like Luther and etc. So it's a high maintenance cost, right? Need specialists to handle the whole clean room, right? So there is a missing link here there's a market opportunity here where we can address, and there is opportunity there here. So this is what we want to fill up the market, the middle part, where for offices, for large room, for public spaces, it become the awareness is actually there's more and more awareness from the public that we do need something like this, like in restaurant, in lobby, library, in teacher, in classroom. So we need something for bigger space, offices, public space with more people inside, that we can process the air in the room, right? We need high air volume fan. We need medical grade H14, but at the same time, we need a powerful fan with a very quiet, very low noise level. It has to be less than 60 dBA, because it's more than 60 dBA, you fail the indoor air quality control standards. And it has to be proper quality maintenance, where after 5 years, 7 years, 8 years, 10 years, people come to you, you can still supply them with the HEPA filters. So this is the market that we want to capture, and we see this is a beginning of this market. It's not the end, it's the beginning. So today I'm going to launch 2 systems that to fill up this market. The first one is the Halo P ceiling mounted air purifier from Erlab. The benefit, the features is, of course, you save space because it's installed on the ceiling. It create a uniform filtration. So because it's center in the middle. So it is for a room size of 35 square meter. If you imagine a large condo units, half or 1/3 of it, the space size. If you have more than that, of course, you can install 2 units. HEPA H14 large HEPA filters. If you can see my screen, do you see my screen? Maybe I can stop the sharing for a while, close my background. All right. Did you see these HEPA filters? All right. So this is for my Hitachi air purifier, right? I didn't change it for 5 years, right? Sorry, I didn't use now, right? So this is how thick. It's very thin, right? So our system is more than, is huge. The HEPA filters from Erlab, HEPA filter from ULT is huge system. For the ULT one, we can go to 2 kilos of HEPA filters. So let's continue. All right. Okay. So this Hello P is very quiet, 52 dBA, less than that. It has smart technology, connect to your smartphone, easy to install, low power consumption, only 50 watt. You can on it. I said programmable. You can program in such a way that it on 8 o'clock to 8 o'clock, or 7 o'clock to 7 o'clock office hour, and then automatically turn off after 8 o'clock in the evening. All right. So there's options for carbon filters. You cannot have two in one. You can either HEPA, Hello P, or Hello C for the carbon filters. All right. So let's go to the another system that I'm going to launch today. This is from German, fully made in German. It's not from China. It's fully made, imported from German, from ULT. The brand name called Sasoo. I'm not sure the German like this name. They call it Sasoo Air Purifier. Right? It's a floor standing type. It looks small, but it's actually very big. Right? Can you imagine the height of this system? The Sasoo Air Purifier is 173 cm. I am 170 cm. Right? My height. So I'm shorter than this system. And the width and the length is 30 cm. 30 cm. All right, so that is how big it is, right? It just plug and play, a single phase. Come with CO2 sensors, because if you install this one in the conference room, you want to know, is there enough oxygen or not? So there's a CO2 indication in this system. This is much bigger system. It is meant for large room. It can go for 1,100 square meter or 1,100 square feet. As I said, one condo unit, you have a condo unit of 1,100 square feet, right? So you can install one for the whole, condo units or your meeting room. It comes with HEPA filter H14 and also carbon filters. You can see how big is the system. The HEPA filters is 2 kilos. The carbon filters is 5 kilos, 2 in 1. Still very quiet, 52 dBA. It's amazing. It's really amazing. Less than 52 dBA. And low consumption, of course, is much bigger than Hello P, the fan. But it's maintenance fee. Customers can change the filter by themselves. It's very easy. All right. Let's go into one by one here. Okay. The first one is the Hello P. I think most of you experienced Hello C. It's a very good product. But Hello C with carbon filters, come with the sensors and come with the carbon filters, are meant for laboratory. But Hello P, not only for laboratory, it can go everywhere, right? It can go everywhere with this. So if you can see the specs here, we do have, beside HEPA, if the customers want Alpha, Alpha basically is 99.9995, okay, percent efficiency. If you want Alpha, yes, we have that options, but of course the Alpha price is slightly more expensive. I want to highlight the Hello P system, which is the HEPA system. If you can see here, the height of the system is more than the Hello C, the one that you installed before, all right? And the fan used is much stronger fan. It has like, there's a mistake here, CFM, but you look at the cubic meter per hour. It is 300 cubic meter per hour. So it covers larger space compared with Hello C. Hello C is 25 square meter. Hello P is 35 square meter, right? So that are the differences between Hello P and Hello C, right? So then come this question. I think those people that is very particular, you want to know more in depth how well HaloP functions. Erlab did send their system to third-party testing lab to run the test, and they published the publication. I will send this publication to you. It's really a journal publication. So I will summarize here so that you can explain to your customers. How they did is basically they put the HaloP in this test chamber. It is a bioaerosol test chamber. As I said, COVID-19 is spread to aerosol, right? So they are putting this HaloP in the aerosol in this closed chamber, and they control the temperature, humidities. At the same time, they emit, the aerosols that contain viruses, which is corona, I think SARS viruses, all right? You can look into the publication. I forgot the actual name, but there's a viruses that put in different concentration of these viruses into this chamber, and let the system run, and they want to know how long it takes to reduce these aerosol viruses in this chamber, right? So it's a very valid experiment design. So this is the result. They run 3 times using these viruses, all right? So the upper part is the control. The lower part, 3 colors are 3 rounds of tests. What it says here is that this, for us, if you look at 15 minutes, there is 1 log. The Y is the Y is a log. How many log reduction of these viruses? So 15 minutes, 1 log is 90%. So within 15 minutes, it reduced 90% of the aerosol, the COVID, the viruses. If you let it run for 90 minutes, what will happen? For 90 minutes, it will reduce to actually almost 0, because this is the level of the HEPA filter efficiency. At the 90 minutes, it reduced 4 log. 4 log means 99.99% of the viruses totally removed, which means contained in the HEPA filters. So there's only 0.01%, left in that chamber. So this is the tabular data that shows 50 minutes is near to 1 log. At the 45 minutes is near to 2 log. 90 minutes is all reached 4 log of reduction. It's actually this MS2 bacteriophage viruses as their test samples, right? So this is a very good publication for those that are very interested on, want to know the science behind HaloP. I will send this publication to you. So I myself is convinced, and it's actually very convincing to customers if they really read through all these publications. Okay, this is Halo. Okay, basically any systems with enough fan volume and also HEPA filters, you can reach that efficiency. So Halo is so this Sasoo is also using HEPA H14. So it has a similar capability, right? So we call this a Sasoo Air Purifier for large room from ULT German. As you can see from this picture, they launched in Europe, but we are the first company that bring to Asia, right? So you can see this is, there's a slot here, and there's an on-off behind the Sasoo. And you can see the upper part is the HEPA filters, 2 kilos. And the bottom part, this one, is the carbon filters. So this is the picture, is an example of what they use in one of the retail shop. I think it's the pharmacy or education center, right? So how does this work? The air inlet is at the top, 173 height, right? cm height. So the air will comes in from the top. We draw the air from the top because the aerosol will actually fill up the rooms, right? You draw from the top down, and the CO2 sensor is at the top as well. And then pass through this black color number 2 HEPA filter H14, which is the clean room standards. and then go down to number 3, which is the 5 kilos of carbon filters to remove the remaining TBOC and gases, and then go down the fan. You can see the fan. Number 4 is the outlet, right? The air will be discharged back to the room. So just plug and play. So there's no sophisticated, installation here. All right, this is how well it functions. It's basically recycle the air, right? So this is the specs. You can see here, sorry, it's 175 cm. The length and width is not 30, it's 60, all right? You can see it's like this big, right? So yeah, it's like one person, one police or standing right, standing there to purify the air for the room, right? 90 kilo systems. So you can actually install this in any facility, sport facilities, fitness center, gym, okay, open office, culture site, restaurant, hotel, conference room, daycare centers, teachers, classroom, sales office, showroom, prayer rooms, everywhere. It can be everywhere, all right? So these systems come in 2-in-1 HEPA filter and carbon filters. And it also has the publications. I will also send this to you. So basically show how well the HEPA filter perform, all right? This is
Mitigating the risk of aerosolized contamination is critical to our fight against this virus. The demonstration you're about to see is performed with the smoke machine generating particles in a 250 square foot room. This first test is performed without the halo on, showing how particles remain suspended in the air and propagating throughout the room without the right efficiency or effectiveness of HVAC. Much like a virus, these smoke particles will remain in the air for quite some time. Unlike a virus, at micron size of 2.5 to 0.125 micron in size, the virus will remain in the air for up to 4 hours. The next demonstration you're going to see is with the halo on, with the same smoke machine generating the same smoke particles. As you quickly can see the effectiveness at capturing these particles and releasing clean air back into the room, drastically mitigating the risk of aerosolized transmission. At Erlab, our sole focus is to design and develop products simply so you can breathe.